Hello again, method students. This example's actually an extra question. It's not on our Chapter 6 notes, but this is actually a question from the 2006 Methods Exam 1. And being Exam 1, it's non-calculator, and it's very much a sketching of a circular function question, so let's get stuck into it. We've got for the function f such that, or the domain is negative pi to pi, f of x is equal to 5 cos of 2 times x plus pi on 3. All right, you can see there's a graph down the bottom here, so we're going to do some graphing, but before we get to that, we're asked to write down the amplitude and period of the function. This should be a pretty easy 2 marks for us. Amplitude, just going by the number in front of the cos, is 5. The period of the graph is, we know it's 2 pi over n for a cos graph, so 2 pi over, in this case, 2. And so the period is pi. Next part of the question says to sketch the graph of the function f on the axis below, labeling axis intercepts with their coordinates and labeling endpoints with their coordinates. So we've got to pay attention to that and make sure that we label everything properly. We can use the techniques we've been using for the last few examples actually, where we think about the graph without a translation. So we know that we've got this plus pi on 3, which is going to translate everything to the left by pi on 3. But if we think about the graph of just y equals 5 cos of 2x, rather than the graph with the horizontal translation in it, then we can actually just start to put some reference points in. We know that a positive cos graph will start at the top and then go down. So with an amplitude of 5, this graph would start at 5. It would also, we know the period is pi, so it would actually come and finish over here when x equals pi, back up at 5. And in between, if we check carefully these grid lines, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 grid lines. So each of these little one grid is pi on 12. So 1, 2, 3, 4, 5, 6. This sort of center point would be down here. That's the middle of our curve. And if we split it into quarters, we've got these two, 1, 2, 3. Being our other kind of reference points, and the rest of the curve would kind of keep behaving the same way if we go back. So I guess each quarter of the cycle is 3 grid lines. So 1, 2, 3, 2, 3, and 1, 2, 3. All right, so without the translation, we'd be getting this graph. But now what we're going to do is take all those points and move them left by pi on 3 units. All right, so we're going, we know from up here, make a note of it, that it's pi on 3 units to the left. So each of those points needs to move across. And if we think about, we said before that each one grid line was pi on 12, so pi on 3 units would actually be 4 grid lines. Each of them is going to move 4 grid lines to the left. Well, let's start with our one in the middle, and we can really start with any of these reference points. We're just going to go 1, 2, 3, 4. It's going to go to here. This one, we're going 1, 2, 3, 4, and so on. This next one, 1, 2, 3, 4, 4, 1, 2, 3, 4. And with what we've sketched here, even though we haven't by no means have finished, we've got enough to see a fair bit of this graph. We've got actually one whole cycle drawn in. Now I'm actually going to leave this next bit of the curve because I don't know yet exactly where my y-intercept is, and I want to make sure that I cross the y-axis at least about the right spot. So I'm just going to leave that little section out. And if I keep going with these reference points, so I hadn't used this one yet. If I move that by 4 grid lines to the left, 1, 2, 3, 4, remembering that what we're actually doing is moving pi on 3 units to the left. We just worked out that that was 4 grid lines. Right, so we can keep going with this. Next one, 1, 2, 3, 4. And this next point, well, that's going to go off the graph, actually, 1, 2, 3, 4. So we've still got some bits to fill in. And going back to my other end here, I've moved this one across. Well, the next one I can actually tell, just from the pattern of my graph, it's going across 1, 2, 3, 1, 2, 3. It's going to come back down here. Right, and I know that it's going to go a little bit further before it hits this endpoint. Right, now, so what I haven't sketched yet is this endpoint when x equals pi. I haven't worked out exactly where this y-intercept is, and I also haven't worked out exactly where the other endpoint is where x equals negative pi. But what we might notice is that all of those should actually have the same y-coordinate. Right, if this graph has a period of pi, well, wherever the y-intercept is, going forward by pi should take me forward exactly one cycle, which means it should come back to where it was initially. Likewise, if I go from the y-intercept back one whole period, I should have the same y-coordinate over here. So I don't have to find 1, 2, 3 values. I only have to find it once and then copy it over here and over here. So I'm actually just going to try to find the y-intercept. And we know that we do that by letting x equal 0. Right, and so what I'm finding is 5 cos of 2 times 0 plus pi on 3. Which is really 5 cos of 2 pi on 3. And if I think of my unit circle, well, 2 pi on 3 is a second quadrant angle. Right, it's the same as saying pi minus pi on 3. Pi minus pi on 3. And so really what that means is I'm trying to evaluate cos of pi on 3, but because cos is negative in the second quadrant, it's going to be a negative value. To work out cos of pi on 3, hopefully you remember it, but if not, sketch your triangle. 1, 2, root 3. Pi on 3 is this angle here, so if it's cosine, the adjacent is 1. Hypotenuse is 2, so the cos of pi on 3 is a half. So this is 5 times negative a half, which is negative 5 on 2, or negative 2.5. So when we go back up here to sketch that on our graph, the y-intercept is here, and it was important that we made sure we got that right, because we wouldn't want our line to cross through down here at 4 or up there at negative 1 or something like that, because we'd be losing marks for that. And as we said, the endpoints will also have the same y-coordinate of negative 2.5 or negative 5 on 2. And now we can finish off our sketch. Right, so everything's in the right place. They're probably faint enough, but you might just want to make sure that these crosses aren't going to be considered part of your working, so I'm going to get rid of those. The last thing we've got to do, as the question asked us to, is to label those key points, the axis intercepts and the endpoints with their coordinates. So the y-intercept was 0, negative 5 on 2. The positive endpoint was pi, negative 5 on 2. Negative endpoint is negative pi, negative 5 on 2. We've also got to put in these x-intercepts. Now, remember the way that we did this, the x-intercepts came from our reference points as they were translated to the left by pi on 3 units. So this point here had come from this value there, which was pi on, to check this properly, that was pi on 4. Right, by counting carefully, yep. 1, 2, 3, yeah, 3 pi on 12, pi on 4. So pi on 4 minus pi on 3, or in other words, 3 pi on 12 minus 4 pi on 12, that gets me to negative pi on 12. And actually, so negative pi on 12, 0. The grid's probably nice enough here that we can actually just count this, so it's probably a more effective way. We could think of the translations, but we could just go, okay, well, if I know that each of these grid lines is pi on 12, and I've done my sketch neatly enough, I could just count these up. So 1, 2, 3, 4, 5 pi on 12 is this x-intercept here. This one here, if I keep counting, 6, 7, 8, 9, 10, 11 pi on 12. And this one down here was negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7 pi on 12. All right, and remember that we're labeling with coordinates, so don't get lazy. Put the coordinates in there, not just the x value or the y value, right? Put both coordinates in for all of them. Let's double check. We've labeled all of the x coordinates, labeled the endpoints, labeled the y-intercept. Yep, we've ticked off everything, and hopefully we've got 3 marks out of 3.